Good morning, children. So in today's class, we are going to discuss about the factor theorem. So in the last class, you have discussed about the concept of zero and the factor theorem. So today, you are going to learn about the factor theorem. What it is, let us see. Supposing 6 is a factor of 12. Factor of 12. What it means? It means that 12 is exactly divisible by 6. If you divide 12 by 6, you will get remainder 0. Say you divide 13 by 6, 6 to the 12, you got 1. So here, remainder seems you did not get 0. That is why 6 is not the factor of 13. But here you got remainder 0. So 6 is the factor of 12. Now, here you will be dealing with the polynomials. Let us discuss. If p of x be a polynomial of degree n greater than or equal to 1 and a be any real number, then p of a equals to 0 if x minus a is a factor of p of x. This is the definition of the factor theorem. Now p of x is a polynomial of degree n greater than or equals to 1. What it means? That means degree is the highest power of the variable. Say you take twice x plus 1. So here the degree is 1. So polynomial of degree 1, or say 4x squared minus 3x plus 1. This is a degree 2. Polynomial of degree 2. So like this it will go. So the n is here natural number. So the minimum is 1, highest is infinite. Now if you divide so by x, so here a is any real number. So real number means all the rational, irrational numbers are all called real numbers, like root 2, root 3, 1 by 2, 5 by 7, 1.25 bar, etc. All these are called real numbers. Now, here definition is that if x minus a is a factor of p of x, then p of a equals to 0. This line is very important line. Now, x minus a is a factor of p of x. That means if you divide p of x by x minus a, it will be exactly divisible where the remainder is 0. So this 0 is the remainder. What I told? X minus a is a factor of p of x. That means if you divide p of x by x minus a, then the remainder you will get 0. Which is that 0? That 0 is this. So this 0 implies the remainder. And this a is what? That is you got from the divisor. So as we have done in the means remainder theorem, divisor equals to 0. X equals to a. So the same thing you will be doing in this factor theorem also. So here putting a, so in place of x, so p of a equals to 0. Why it is 0? Because x minus a is a factor of p of x. Now this is given in the book, so you will go through the book and you will get it. So this is the definition of the factor theorem. Now today we will be doing some sums relating to this factor theorem. Let's take even a question from the textbook. So you take textbook exercise 2.4. 2.4. There the question number 1, it is given that determine which of the following has x plus 1 as a factor. Let me take number 2 from the table. Now, children, they have asked that you are to find out, you are to check whether x plus 1 is a factor of this polynomial or not. Now, you will name this polynomial. So, solution. Let p of x equals to x to the power 4 plus x cubed plus x squared plus x plus 1. Now, this is the divisor. This is the divisor and this one is the dividend. So, you will make the divisor equals to 0. So, x plus 1 equals to 0. So, x you got minus 1. Now, in place of x, you are going to put minus 1. So, all this x will be replaced by minus 1. And if the result is 0, then by the factor theorem, x plus 1 will be the factor of p of x. Now, p of minus 1. So, in place of x, so it is minus 1. Minus 1 to the power 4 plus minus 1 whole cube plus minus 1 whole square plus of minus 1 plus 1. So, equals to, the power is even, sign will be plus. So, it will be 1 to the power 4, it will be 1. The power is odd, sign will be minus. So, it will be minus 1. The power is even, sign will be plus. Then, plus into minus, minus 1 plus 1. So, minus 1 plus 1 got cancelled. So, you got here 1 plus into minus, minus 1 plus 1 plus 1. So, plus 1 minus 1 got cancelled. You got result is 1, which means this is the remainder. So, since you got remainder 0, so therefore by the factor theorem, x plus 1 is not the factor of p of x, because to be a factor you should get the value 0. If you get 0, it means that the remainder is 0. In that case, by the factorial theorem, x plus 1 will be a factor of p of x. But here you got 1, not equal to 0. So therefore, x plus 1 is not the factor of p of x. How did you get this? From factor theorem. So you will get factor theorem. So now here they have asked the question, determine which of the following has x plus 1 as a factor. So you have named this one by a notation p of x. So variable is x, so you took x. If it is in y, you will tell p of y or f of y, anything. Now the divisor is x plus 1 because you are going to divide by x plus 1. So you make the divisor equals to 0. So you got x as minus 1. So in place of x you put minus 1, result you got 1. Since you did not get 0, therefore by the factor theorem, x plus 1 is not the factor of p of x. Next, let us take question number 4. Number 4, it is x cubed minus x squared minus of 2 plus root 2 into x plus root 2. Now, so the question is the same. Determine which of the following has x plus 1 as a factor. Let us name it. Let p of x equals to x cubed minus x squared minus 2 plus root 2 x plus root 2. Now the divisor is x plus 1, make it equals to 0. So x plus 1 equals to 0, so x equals to minus 1. Now in place of x you are going to put minus 1. So Therefore, P of minus 1 equals to all these x values will be minus 1. So it will be minus 1 whole cube plus minus 1 whole square minus 2 plus root 2 minus 1. So this x is minus 1 plus root 2. Now simplify. The power is odd, the sign will be minus 1 cube, so it will be 1. The power is even, sign will be plus, so plus into minus it will be minus. The power is even, sign will be plus, plus into minus, minus. 1 square is 1. Now minus into minus, minus into minus plus, so it will be plus, so 2 plus root 2, then plus root 2 equals to minus 1 minus 2 plus 2 plus root 2 plus root 2. So minus 2 plus 2 got cancelled. Now these are the two like cells because they are the same root 2, root 2. If you add these two, how much you will get? Root 2 means 1 root 2, another root 2. So it will be 1 root 2. Add it. You will get twice root 2. So you did not get the remainder 0. This one is called remainder. Remainder is not equal to 0. Therefore, x plus 1 is not the factor of p of x. Therefore, x plus 1 is not the factor of p of x. How did you get this? From factor theorem. So factor theorem. So it is very simple. So I have done there were 4 sums. I did 2 sums. So you do the remaining 2 sums. And all this you will get in the PDF file that will be sent. Let us take exercise 2.4. 2.4, question number 2. Use the factor theorem to determine whether g of x is a factor of p of x. Factor p of x. Now we will take the first equation. P of x equals to twice x cubed plus x squared minus 2x minus 1. G of x, it is x plus 1. So the question is giving very clearly, you use the factor theorem to determine whether g of x is a factor of p of x. If g of x is to be the factor of p of x, then you should get the value 0. So let us see the process. So here solution. So here this is the dividend because they have asked that if g of x is the factor of p of x or not. So that is why this will be the dividend and this will be the divisor. So you have to make the divisor equals to 0. So p of x equals to twice x cubed plus x squared minus 2x minus 1. Now this is the divisor. Make the divisor equals to 0. So x plus 1 equals to 0. So x you got minus 1. Now you are going to put, so in place of x, minus 1. So p of minus 1 equals all these values of x will be replaced by minus 1. So 2 into minus 1 whole cube plus minus 1 whole square minus 2 into minus 1 minus 1. So equals to 2 into power is odd, sign will be minus, so minus 1 it will be. Then plus, the power is even, sign will be plus, so it will be 1. Minus into minus, it will be plus, 2 into 1, 2, minus 1. So you will get plus into minus, it will be minus, 2 into 1, it will be 2, plus 1, plus 2, minus 1. So plus 1, minus 2, plus 2, you got 0. That means since the remainder is 0, so by factor theorem, g of x is a factor of p of x because the remainder you got 0. So therefore by factor theorem, g of x is a factor of p of x. So the remainder should be 0. If you get values other than 0, then g of x will not be the factor of p of x. So here let me tell you once again. So g of x is the divisor, p of x is the dividend. So you are to divide the dividend by the divisor. So you take the divisor equals to 0. So the divisor was x plus 1. So you took equals to 0 and you got x is minus 1. Now in place of x you are going to put minus 1. So all these values of x will be minus 1. So you have simplified and then you got 0. Since the remainder is 0, therefore g of x is a factor of p of x. Let us take number 2. P of x equals to x cubed plus 3x squared plus 3x plus 1. G of x equals to x plus 2. Now the same question, you are to test it that whether g of x is a factor of p of x using the factor theorem. So the same case, this is the dividend, this is the divisor. So you make the divisor equals to 0. So here the divisor is x plus 2, this is the dividend. So let's take as the solution. So here x plus 2 is equal to 0. So this gives x equals to minus 2. So now x will be replaced by minus 2. So p of minus 2 equals. So all these x values will be now minus 2. So it will be minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 1. Power is odd, sign will be minus 2 cube, that will be 8 plus 3 into the power is even, sign will be plus 2 square, 2 into 2 4 plus into minus 3 into 2 6 plus 1. So you got minus 8 plus 12 minus 6 plus 1. So minus 8 minus 6 minus 14 plus 12 plus 1, it will be plus 13. So you got minus 1. So you did not get the remainder 0. Remainder you got minus 1. That is why by the factor theorem, g of x is not the factor of p of x. So therefore g of x is not the factor of p of x. So by factor theorem, it's very simple, children. Almost the sums are looking similar. So to be the factor, remainder should be 0. And here one more point, you are to make the divisor equals to 0. That is the thing. So then proceed in the same way. So the result should be 0. If the result is 0, then definitely g of x will be the factor of p of x using the remainder theorem. Let us take question number 3. Find the value of k. Find the value of k if x minus 1 is a factor of p of x. P of x. Let us take number 2. P of x equals to, so twice x squared plus kx plus root over 2. So the questions are little bit twisted, more or less they are the same. Here they have asked you to find the value of k. Find the value of k, this value k, if x minus 1 is a factor of p of x. That means they have given that x minus 1 is a factor of p of x, which means that if you divide p of x by x minus 1, remainder equals to 0. So here they have already declared. So it is given that x minus 1 is a factor of p of x, which means p of x is instantly divisible by x minus 1, where the remainder will be 0. Solution. So p of x equals to twice x squared plus kx plus root 2. So you are going to divide by the divisor, that is x minus 1. So you will make the divisor equals to 0. So x minus 1 is equal to 0, x equals to 1. Now here, just to see, you want to find this value of k if x minus 1 is a factor of p of x. That means here it is given that p of x is exactly divisible by x minus 1, which means remainder is 0. So now by factor theorem, so here p, so x is 1. So in place of x you put 1 equals to 0. Why it is 0? Because x minus 1 is a factor of p of x. They have given that p of x is exactly divisible by x minus 1, which means that here the remainder you will get 0. That is why this 0 implies remainder. So now in place of x you will put 1. So p of 1 equals to 0. So it is the remainder 0 because why? Because here x minus 1 is a factor of p of x. Now you replace x by 1. So here 2 into 1 square plus k into 1 plus root 2 equals to 0. Now simplify. So 2 you will get plus k into 1, it will be k plus root 2 equals to 0. Now how much will be k? So k equals, taking this irrational number, rational number to the other side. So there is plus, it will be minus root 2. There is plus, it will be minus 2. Now you cannot simplify because they are the, one is the irrational number, other is the rational number. So you cannot simplify. This is your answer. So k is minus root 2 minus 2. This is your answer. So here, let me tell you again, why we took here p of 1 equals to 0. How did this means 1k from the divisor. So the divisor is x minus 1. You have made the divisor equals to 0. So you got x as 1. So in place of x, you have put 1. It is the 0. So this 0 is the remainder Why this means 0? Because x minus 1 exactly divides p of x, which means remainder you will get 0. So that 0 is this 0, remainder indicative. Let us take number 3. So p of x kx squared minus root 2x plus 1. Now the same question, you are to find this value of k if x minus 1 is a factor of p of x. That means p of x is exactly divisible by x minus 1. So the remainder you will get 0. So you make the divisor equals to 0. So here solution p of x equals to kx squared minus root 2x plus 1. Now x minus 1 equals to 0. So x equals to 1. Now in place of x you put 1 and then the remainder you will get 0 because x minus 1 is a factor of p of x. Now by factor theorem, so now here this value of x will be 1. So p of 1 equals to 0. So this leaves, now all these x values will be 1. So k into 1 square minus root 2 into 1 plus 1 equals to 0. So this gives k minus root 2 plus 1 is equal to 0. Now you need to find the value of k. So you take this rational number to the other side. So k equals minus is there, so you take to the other side will be plus 1, it will be minus 1. Now you cannot simplify. So this is your answer. So the value of k is root 2 minus 1. So they are the very simple many questions. I have done the sums, so you go through the PDF file also, there in detail I have done. It will be more clear to you. So today we will learn a few questions on factorization. So we have learned in class 8. So in class 8 you have learned factorization. So today we will be learning few on it. So some identities that you have got in class 8. Number 1, you got a minus b whole square equals to a square minus 2ab plus b square. Then you got a plus b whole square is equal to a square plus twice ab plus b square. Then you got a square minus b square equals to a plus b into a minus b. These three identities you have learned in class 8. Now you will get more identities, so that we will get in the subsequent classes. So today we will be just learning few of them. So from the same exercise, there is 2.4. Let us take one factorization. Question number 4. Factorize. Let us take 1. 12x squared minus 7x plus 1. Now, children, you see, in these two identities, you have got two perfect squares, a square, b square, perfect squares. You see a square, b square. So here you see, here the terms are 3, 12, 7 and 1. 1 can be made 1 square, you will get 1. But this 12 and 7 cannot be made perfect squares, so you cannot use this identity. So now here, what is the way that we can do? And you have got all the concepts in class 8. What you will do is you are going to split this middle term. That is called splitting the middle term. You have got in class 8. Splitting the middle term. Middle term. That means this 7 is the middle term. You are going to make it into two parts. So now, how to do? Let us see. So the process is you take the coefficient of x squared, that is 12, and the constant. So the constant is 1, coefficient of x squared is 12. So 12 into 1. So 12 into 1, you got 12. Now you add this to 12 plus 1, 12 plus 1, you got 30. But there is 7. This one is not possible. Rejected. Then you subtract also 12 minus 1, you got 11. But there is 7. So you did not get 7, so rejected. Now you take a different pair so that you should get 12. 4 into 3 is 12, 6 into 2 is also 12. So 4 into 3, you took 12. Now you add these two. 4 plus 3, you got 7. So you have got here 7. What I did, children, once more. So as there are no two terms, perfect squares like a squared, b squared, so these two formulas cannot be used. So now the only process left is the splitting the middle term. So this is the middle term. You are going to split 7 into two parts. How to do? You will take the coefficient of x squared, that's 12, and you take the constant. Then 12 into 1, 12. Now you add this to 12 plus 1, 30, but you need 7. So it is rejected since you got 30. Then 12 minus 1, 11, but there is 7. So rejected. So they cannot come. Next you take a different pair, multiply them so that you get 12. 4 into 3, 12. Now you add this to 4 plus 2, 7. So you got 7. That means 7 can be split into two parts, 4 and 3. So equals to 12x squared minus 7. 7 will be 4 plus 3x. So it is 7x. 7x plus 1. So here you have seen that 7 is split into two parts. This is the middle term. So equals to 12x squared minus 4x. Then minus into plus, minus 3x plus 1. Now, between these two factors, you take the highest common factor. Between these two, you take the highest common factor. So, between these two, the highest common factor is 4x. So, it will be 4x. Why it is 4? Because 4 will divide 4 and 4 is going to divide 12 also. Between x and x squared, the lowest power. Between x and x squared, the lowest power is x because their power is 1. So, you do 4x. So 4 3s are 12. X into x, x squared. That means 4x into 3x, you will get 12 x squared minus 4x. How many is a 4x? 1. 4x, 1 is a 4x. Minus into, but between this 3x and 1, there is no common term. So that time you will take 1 because there is no common term. So that time you take 1. 1 into 3x, you will get 3x. Minus into minus, minus into minus will be plus. 1 into 1, 1. Now you see, when you will split the middle term, then you should get one common factor. So the common factor is 3x minus 1. If you do not get this common factor, that means something is wrong. So now, since you have got these two common factors same, that is 3x minus 1. So you take 3x minus 1 common, and then you take the next factor, that is 4x minus 1. 4x minus 1. So it is factorized. So these are the two factors. If you multiply 3x minus 1 with 4x minus 1, you will get 12x squared minus 7x plus 1. So this is the process. You have done it through splitting the middle term. Let us do one more. So in the next class we will discuss this in detail. Number 2, 2x squared plus 7x plus 3, 7x plus 3. Now here you see there are total 3 terms and 3 is not a perfect square, 2 is also not a perfect square. So you cannot take a square, b square twice. So the only process left is you are going to split the middle term. So same way, coefficient of x square is 2, constant is 3. So 2 into 3 you got 6. But 2 plus 3 that is 5. But you need 7. So it cannot happen. Then you take next pair. If you multiply, you should get 6. 6 into 1 is equal to 6. So you got 6. Then 6 plus 1. 6 plus 1 you got 7. So it is 7. That means this one is yes. So you can take. So twice x squared plus 7. 7 will be 6 plus 1. So 6 plus 1 x plus 3. So here 2x squared plus 6x plus into plus plus, you will get x plus 3. Between these two terms, the highest common is twice x. Because both 6 and 2 are divisible by 2. So it will be 2. And the lowest power of x is x. So it will be x. Then it will be 3x. 2 into 3 is 6. X into x, x squared plus. So it will be 3. Because 3 into 2x, it will be 6x. Then plus. Between these two terms, so twice x into x, twice x squared plus 2 into 3x, 6x. Between these two terms there is no common, so you will take 1. So now 1 into x, it will be x, plus into plus, it will be plus, 1 into 3, it will be 3. Now you see these two are same. That means your factorization is correct. So equals to, from these two you take a common factor x plus 3 and from the remaining, so twice x plus 1. So here this one is factorized. So in the next class we are going to discuss about factorization. So for today I am just coming to an end of today's class. So you go through all this. I have given in detail in the PDF file. So there you see, you will get everything. So thank you.